Hello, science fans. Get ready to dive into a world that governs everything around us. Ever wondered why a ball falls down, pulled towards the earth with unwavering certainty? Or how your microwave heats popcorn, transforming those tiny kernels into a fluffy snack with incredible speed? Or what makes a rainbow, that stunning arc of color that appears after a refreshing rain? The answer is physics, the science that explains how everything in the universe works, from the smallest subatomic particle to the largest cosmic structure. It's not just about complex equations or lab coats. Physics is the rulebook for reality, the fundamental principles that govern all interactions and phenomena. It all starts with atoms and extends to galaxies, spanning the vastness of space and time. If the universe were a play, physics would be the script, dictating the actions and interactions of every element, telling every actor, planets, stars, light, each following precise laws and predictable patterns, and even you, how to interact with the world around you. Understanding physics is like getting a backstage pass to the universe's special effects, revealing the mechanisms behind the magic. It's a way to see the extraordinary in the ordinary, uncovering the hidden principles at play in our daily lives. And it all starts with a simple question: why? Why does this happen, and how does it work? Physics isn't just for scientists, it's everywhere, every day, woven into the fabric of our existence. Riding a bike, listening to music, or switching on a light, all are physics in action, demonstrations of fundamental principles at work. By learning the basics, you'll see the hidden science behind everything, gaining a deeper understanding of the world around you, from your phone to the sun and everything in between. So let's start our adventure. We'll explore the building blocks of reality, the fundamental particles that make up all matter, the energy that drives it, the force that powers our universe, the forces that shape it, from gravity to electromagnetism, and the rules that keep it all in motion, ensuring the continuous dance of the cosmos. Ready to become a physics explorer? Let's go. The universe awaits our discovery. Let's start with the basics. What is everything made of? Matter. It's anything that has mass and takes up space. Your chair, the air, the stars. Matter comes in three familiar states: solid, liquid, and gas. Think of water. Ice is solid, liquid water flows, and steam is gas. Same stuff, different arrangements. Zoom in on a drop of water and you'll find atoms, the building blocks of all matter. Atoms join to form molecules, like H2O for water. The periodic table lists all the different types of atoms: oxygen, carbon, gold, and more. Physics often explores how these atoms and molecules behave, how they stick together, fly apart, and create the world's complexity. Understanding matter is the first step to understanding the universe. Everything, from your body to distant stars, is made from these fundamental particles. It's wild to think you're made of the same stuff as the stars. So next time you look around, remember, it's all matter and it all follows the rules of physics. Let's keep going. If matter is the stuff of the universe, the building blocks that make up everything we see and touch, energy is what makes it move, what animates it, and allows it to change. Energy is the ability to do work. It's the driving force behind all activity: move things, heat things, or make things change. It's the catalyst for transformation. Without energy, nothing would happen. Everything would be frozen in place, static and unchanging. It's the universe's ultimate mover, the engine that drives all processes, big and small. One key rule: energy can't be created or destroyed, only transformed from one form to another. This is the law of conservation of energy, a fundamental principle that governs the universe. For example, a flashlight's battery stores chemical energy, a form of potential energy waiting to be released, which becomes electrical energy, flowing through the circuit to power the bulb, then light and heat, illuminating our path and warming our hands. Energy comes in many forms. It's a versatile and adaptable resource: kinetic energy from motion, the energy of movement and action, potential energy that's stored, waiting to be unleashed, thermal energy, and more. The possibilities are endless. A moving car has kinetic energy. The faster it goes, the more kinetic energy it possesses. A book on a shelf has potential energy due to its position relative to the ground. When you eat, your body turns food's chemical energy, the energy stored in the bonds of molecules, into the energy you need to move and think, powering your muscles and fueling your brain. Power plants transform energy from coal, wind, or atoms, harnessing the power of nature and technology into electricity, the lifeblood of our modern world. Energy is the currency of the universe. It's always changing form, constantly being converted and utilized, but the total amount stays the same, a testament to the fundamental laws of physics. Understanding energy helps us understand everything from running a marathon, pushing our physical limits, to powering a city, sustaining our complex and interconnected society. Let's see how energy and matter interact through forces. Get ready to explore the dynamic relationship between these fundamental components of our universe. We have matter and energy, but how does energy make matter move? Through forces, a push or a pull. Forces start, stop, or change the direction of motion. Kicking a ball, picking up a book, or stopping a cart all involve forces. Everyday forces include friction, slows things down, tension, pulls in ropes, and the normal force supports you on the ground. Some forces act at a distance, like gravity and electromagnetism. Gravity pulls everything together. Electromagnetism makes magnets stick and holds atoms together. Sir Isaac Newton described how forces work with 3 laws of motion. Objects stay at rest or move unless acted on. Force equals mass times acceleration, and every action has an equal and opposite reaction. Forces are the directors of motion in the universe. They explain why things move, stop, or change direction. Understanding forces lets us predict and control motion, from launching rockets to riding bikes. Next, let's dive into the science of motion. Motion is everywhere. Cars driving, balls flying, planets orbiting. Physics describes motion using speed, velocity, and acceleration. Speed is how fast something moves. Velocity is speed in a specific direction. Changing velocity, by speeding up, slowing down, or turning, is called acceleration. Even turning a corner at constant speed is acceleration because direction changes. Newton's laws connect force, mass, and acceleration. A force causes acceleration, which changes velocity, resulting in motion. These concepts help us predict everything from a thrown ball's path to a planet's orbit. Motion isn't just about going fast. It's about how and why things move. By understanding motion, we unlock the secrets of everything from falling leaves to spinning galaxies. It's all about pushes, pulls, and changes in pace. Now let's look at the force that rules them all: gravity. Ready? Gravity, an invisible yet ever-present force, is what keeps your feet firmly planted on the ground. It's the reason you don't float away into the vast expanse of space every time you take a step. It's also the same force that governs the grand dance of the cosmos, keeping the planets in orbit around the sun, ensuring they follow their celestial paths. At its core, it's a universal attraction, a fundamental property of the universe that exists between any 2 objects that possess mass, no matter how big or small. Though this attraction exists everywhere, you only really notice its effects when at least one of the objects involved is truly huge, like our own planet Earth. The legendary story tells us that Newton realized gravity is the force that relentlessly pulls apples from the tree down to the ground. He also understood that it's the same force that tirelessly keeps the moon circling Earth in its perpetual orbit. It's more than just a force, it's a fundamental aspect of the universe, a force that shapes the cosmos on the grandest scales. The strength of gravity isn't constant. It depends directly on the amount of mass involved and the distance separating the objects. In essence, more mass or less distance between objects translates to a stronger gravitational pull. The sun's immense gravity is what holds all the planets in our solar system in their respective orbits. Similarly, Earth's gravity is what keeps us grounded, preventing us from floating off into space. Astronauts in orbit experience a unique sensation. They feel weightless. This is because they're in a state of constant free fall, perpetually moving around Earth at the same rate as their spacecraft. But Einstein took our understanding of gravity to a whole new level. He proposed that gravity isn't just a force pulling things together, but rather a curvature in the very fabric of space and time itself. According to Einstein, massive objects warp and bend space-time around them, and other objects, like planets and stars, simply follow these curves in space-time. To visualize this, imagine placing a bowling ball on a trampoline. The bowling ball creates a dip, and smaller balls placed nearby will naturally roll toward it, following the curve. In this way, gravity acts as the architect of the universe, shaping its grand design. It governs everything, from the simple act of an apple falling from a tree, to the majestic swirling of galaxies across billions of light years. Now, let's shift our focus and see how another fundamental force, electricity, powers our modern world. Electricity has transformed our world, but it all comes down to tiny charged particles, electrons and protons. Electricity is the flow of electrons. Opposite charges attract like charges repel, that's the basic rule. When electrons move together, you get an electric current, powering everything from lights to laptops. Think of a circuit. A battery pushes electrons through wires, lighting a bulb or spinning a motor. Electricity and magnetism are linked. Moving electric currents create magnetic fields, and changing magnetic fields can create electric currents. This is how generators and motors work, powering cities and gadgets. Understanding electricity lets us harness energy, communicate, and build the modern world. It's a beautiful dance of forces that lights up our lives. Next, let's see how physics shapes your everyday experiences. Ready to spot physics in action? Physics isn't just in labs, it's everywhere. Your smartphone uses electricity, GPS relies on relativity, and its chip is built on solid-state physics. In the kitchen, popcorn pops because water inside turns to steam, building pressure until it bursts. Physics in action. Microwaves heat food by vibrating water molecules, turning energy into heat. Your fridge, kettle, and even your bike all use physics principles. Thermodynamics, levers, gears. Cars convert chemical energy in fuel to kinetic energy. Airplanes use air pressure to fly. The colors you see are different wavelengths of light. The music you hear is sound waves. Sports, cooking, and even making coffee, all are governed by physics. Physics explains the how and why behind your daily life, turning the ordinary into the extraordinary. Once you see it, you can't unsee it. Physics is the fabric of reality. Every moment, you're living in a world shaped by these rules. Let's wrap up our journey. That's our whirlwind tour of physics. We've seen how matter, energy, and forces shape everything from atoms to galaxies. Physics is the universe's language. Learn it, and you can read the story of reality. Understanding these basics gives you the power to think critically, make informed choices, and appreciate the technology around you. Physics sparks curiosity and wonder, helping you see the world in a new light. And this is just the beginning. Quantum mechanics, cosmology, and mysteries like dark matter await. The adventure never ends. Physics is always evolving. Stay curious, ask questions, explore the world with fresh eyes. You don't need to be a scientist to appreciate the beauty of physics. With a little knowledge, you have a passport to the universe. Ready to travel, discover, and understand your place in the cosmos. So go on, explore. The world is waiting.